So, I wanted to jump on today with Jordan Anderson, who is the CTO
Well,
of what was Notia Point is making some major changes, which we're going to have another stream coming out here soon talking about like what's happening with Notia Point, what are
we're
these changes going on?
restructuring.
Yes, exactly. And a little preview is the new company name is Cloud Underground. And if you followed me on LinkedIn and things like that, you've probably heard of the Cloud Underground even before we started the DevSecOps Dojo, because the DevSecOps Dojo's purpose was to create this idea called the Cloud Underground. So, anyways, one thing I want to talk about today is Kubernetes and hardware, because you can play with Kubernetes on just about, well, so many different types of hardware, including things like a Raspberry Pi. And so, like, we even use Raspberry Pis for our development. And some of the things that Jordan especially works on is he's very much so a hardware person. I'm very much so a hardware person. And, whether it's like Raspberry Pis or your servers, like Kubernetes will run on all kinds of things. So for people who want to get into the kinds of like work, like what is all this stuff in the background? Like this is stuff that's run on container images built for Kubernetes, and so that's more or less what we do. So I guess Jordan, when you first heard of Kubernetes, did you what were your first thoughts of like, because it's such a confusing concept. Because I know a lot of people watching probably don't even know what Kubernetes is, but some of you are starting to get an idea from watching.
Sure. Well, and I mean, I came in, I guess, with the understanding and mindset of Docker. So I think that kind of helped me wrap my head a little bit around Kubernetes, although they do different things. But yeah, I mean, just essentially the ability to cluster a bunch of nodes, different hardware together that makes essentially a single entity that then is redundant and basically pretty resilient against crashes and hardware malfunctions and things like that. So it's pretty neat technology. It's really interesting stuff.
It is really interesting. It's because it's like one way we could put it is like it's the like cluster anything together technology. Let's see.
Sure.
I'm just gonna type it
Yeah,
in
and
real
your
quick.
cluster doesn't even have to be all the same type of hardware. I mean, you can mix and match to some degree, and it's pretty interesting.
That's the part that really gets me is like with other types of software, you have all these different types of limitations. But the thing about Kubernetes is designed to run on different types of things and allow those things. And by things we mean hardware, of course. So it's like it's such a nebulous concept of like, well, what do you run Kubernetes on top of? Well, you could run it on a
Sure.
Raspberry Pi, or you could run it on like the systems that we run on. Like, what's your desktop built out of, Jordan? Because your desktop has all kinds of things in it, and you can run Kubernetes on that too.
Sure. Yeah. Well, I mean, I'm running one of the newer AMD processors. So I've got a 3800X, which is an 8-core 16-thread processor, and I have 64 gigs of RAM. So I've got quite a bit of that to play with. So yeah, I mean, absolutely. I need to set up a couple VMs or something that runs Kubernetes. It'd be fun. Be fun to get some x86 hardware with it, because
That's one
we've only
thing.
been playing
Yeah,
with ARM at this point.
it's true that we've spent so much time with ARM. So just like Jordan said, like even like this dashboard right here, this is built off of a Docker backbone built for Kubernetes with full-on monitoring. For anyone who's used Grafana, you've probably seen this before. There's something called Promtail, but if we take for any of those who are nerdy enough to know exactly what this dashboard is and wondering what's sitting slightly under this dashboard, we can go over to configurations here, and you can see that there's we're using Loki and basically like a prom Loki, which lets us use Grafana like a security information and event management system, which is lets us build these beautiful dashboards for things like home security. So if we want to know if there's some weird things going on, then we can tell. But really, all of this is built on ARM. So this is built on a bunch of Raspberry Pis. This runs on 3 Raspberry Pis to be precise. And while this is running on top of Raspberry Pis, anyone who I guess works in like the development space or anything like that is probably familiar with Kubernetes running on something much beefier than a Raspberry Pi.
Mm-hmm.
So, you know, these like massive data center servers. So this is something that's just the interesting thing about the fact that you can just install Kubernetes on anything is Kubernetes is something that you, like more or less when you go into the enterprise development space and you're trying to work with continuous tech board right here. This is running on top of a continuous technology, which is probably Kubernetes based. So you're probably staring at Kubernetes through the screen right now, whether you know it, because Kubernetes kind of oftentimes runs the backbone of a lot of applications that you see on the internet. And it's just so interesting to me that you don't have to have the most expensive hardware to run some of the most, I guess, advanced technologies, which Kubernetes expensive, because I've been thinking about this lately, because building with Kubernetes is very expensive, whether it's for a hobby or not. But what it's expensive with is your time, because
Yep.
Kubernetes is so time consuming. And so that's one thing that I've run into is when you're trying to teach people Kubernetes, like if people have to come up with a lot of money and they have to have a whole bunch of time and stuff like that, what it makes it is Kubernetes tends to be really hard to learn with. I guess
Yeah.
I'll just outline that as costs and time. I'll just say costs and time make it hard to learn Kubernetes.
Yeah, I mean, it's easy to have the infrastructure to do it. It's just a matter of taking the time to figure it all out and actually set it up correctly.
It's so true because it's like, I don't know. I think like how long did it take us to start building the Olympiad? Because if we go all the way back, and I'll just timeline it out right here. I think when we started working on it was 2019, like late 2019, maybe
That sounds right.
November is like when the first discussions of it really like came on,
Hmm.
and it was called the Assault Grid. But if I just draw out like a little timeline real quick, you think about like how long does it take to build something that you're trying to develop with a technology like Kubernetes? And then why is it that companies are willing to pay people who understand these things so that companies don't have to waste a lot of time and money on stuff? Because really, this stuff takes so much time that imagine if you're a company trying to get a Kubernetes developer or someone like that who works with like container images and things like that and can work with like Golang and Terraform and all this stuff with containers and Kubernetes. They're probably getting paid a lot of money. So when they're not able to do certain things, then it hurts a company because it's very expensive and things take too long. So if you hire someone to be a Kubernetes developer who doesn't know what they're doing, then this person will take all this time while you're paying like tens of thousands of dollars a month on this person to learn, and that's just painful. That can be very painful for businesses. And one thing I should do is try to see if I can look at the chat because on YouTube anyways.
Oh,
Let's see. I haven't looked at the chats in so long because it's like we multi-stream, so we're on LinkedIn, Facebook, and YouTube. So I guess right now I'll go ahead and watch the YouTube chat if anyone so happens to come by YouTube, and then. If you're on LinkedIn, then hello. Lately, I've been watching the LinkedIn chats, and I've not watched some of the other chats lately. But anyways, so like, how long did it take us to develop some of the stuff that we're doing for Kubernetes? And we're still right now we're just getting to where it's getting packaged, right?
yeah.
And like this has been a full-time endeavor with a whole bunch of people, including both of us and Laura and our entire community and people who've worked with things, and we've had to get lots of customers to help make it capable for us to be able to keep affording these things, and then and so it's quite the journey to think, okay, so we started building something for Kubernetes in 2019. So I'll just, I guess, put a tag there as we started building some software. There we go, and hardware together actually, because
Yep.
a little further down the line after the software, we started working on that. Then, really, I would say in 2020 sometime, early 2020. So I guess I'll just add early 2020. We started actually thinking about hardware too.
Well, and I mean, even in the beginning, when you guys were developing the Assault Grid, you kind of identified the Raspberry Pis as a cheap way to deploy that. So
That's true. Yeah. Because it's so expensive to try to, like, you have all these other costs where you don't want to incur more costs than you already have when you're trying to build like a software project, because it's like you have limited time, especially if you're doing this stuff full time where you're like you have to make rent on it at the same time while building it. That gets complicated. And so we started then doing custom hardware engineering right around here. So because something that we ran into was, so since I come from more of the, I guess, big data space, dealing with like security information management, things like that, and security operation centers and like dashboards for security, like this right here is a security operations center dashboard. That's what this is. So for those who don't necessarily know what a SOC or security operations center is, it's designed to show things like, am I getting hacked? Is my house safe right now? Is my company safe right now? And so we set up tools to make it so that we can identify, you know, what have the last like 24 hours looked like, or maybe what have the last X amount of time looked like, or whatever we're trying to figure out and see right here. Before it was showing just a small segment of time, but since I just updated it, it's like this is, you know, what the days looked like. But when we're trying to figure this stuff out, like I can tell if someone's trying to SSH into my environment. I can figure out who and where they're coming from if they're trying to do all that stuff. And so if you don't know what SSH is, then that's another thing that I won't go into a rabbit hole over. But the bottom line here is that, you know, it takes a long time. And when you're trying to build for something like Kubernetes or some of these other things, anything you can do to standardize, we had, and I'm just going to make this a colored card, as we ran into a need for standardization because Kubernetes almost gives you too many options and too much flexibility. So, you know, one thing I will say is, because Kubernetes, you can build it on top of just about anything, which kind of adds some confusion and a little chaos, because you're like, okay, so I want to build a Kubernetes cluster. It's like, okay, well, what kind of Kubernetes cluster? It's like, well, okay, so let's take a look. So we have things like Raspberry Pi, and you know, you can build a Kubernetes cluster with that. We have things like Jetson Nanos. You can build a Kubernetes cluster with these things, which I'll just pull up some images here. So if anyone's never heard of a Jetson Nano, it's kind of like a Raspberry Pi, but not quite. And then also, you might have some old ancient laptop, right? You could go put Kubernetes on your old laptop. And and the part that's the most interesting to me is not only can you have Kubernetes on your old ancient laptop, you can have it on a Jetson Nano, you can have it on your Raspberry Pi, but let me just show you something that makes Kubernetes kind of an interesting creature. Is we're trying to build some sort of software, build some platform, build something that's going to be helpful for people, really, especially for like security and for developers, tools for developers. We build developer tools. That's what we do. But let's say that you're trying to figure out what you want to build on. It's like you have option overload. So you can have a Pi, a Jetson, a laptop, and some giant server of some sort. Like I have a server, Jordan has a server, and then, you know, we have laptops and things, and you have all this stuff. The interesting thing about Kubernetes is you want to standardize something that you're building on, but interesting as it is, you can actually make all of these like work together as like one computer. So if I don't know how to represent that, but maybe I'll just like mash potato them all together. you can just say, hey, I want all of these to work together like as one collaborative supercomputer with processes, and then bam, put Kubernetes on them all. And this is this is when we start to get into something called like a hybrid cloud. And this is when Kubernetes just starts to get bizarre. And so this is where it's like, okay, so if we're going to be spending a lot of time helping people build with Kubernetes, building with Kubernetes ourselves, doing things, well, if we don't standardize, if we don't try to find out like, okay, so what do I want to just kind of use as a foundation here, then we just like kind of end up in this bubble of madness. And so in order for things to not take longer than they need to take, we ultimately are like, okay, how do we decide which one of these sets of hardware to standardize on? Because we could use, Windows computers, Linux computers, Apple computers. We could use the laptop flavor or the desktop flavor of any of the above. We could use so many things that we'll end up just getting dizzy and not having an idea. So the easiest way to simplify it is, what's the lowest cost that gives you the appropriate amount of power that's going to let you develop like whatever you're trying to develop for like business uses. So, we did some thinking, and what we came to find is that the thing that lets us build for everything, whether it's a giant server or a Jetson or a laptop, is a Pi. And so we had been using Raspberry Pis in general, but since we'd been using Pis to save cost during the development phase, at one point we were trying to consider, moving our development beyond Pi, but it just complicated things. So we were just like, you know what? Why don't we just use these? Because whatever we develop on a Pi can be used on a giant server. So why would I go and spend 10 grand on on a giant server to develop on? And that could be, it doesn't have to be 10 grand. It could be $1,000. But it doesn't matter whether it's $1,000 or $10,000. It's still
or
not
$100,000.
Right? Like, it's not gonna beat like an 8 gig Raspberry Pi. That's like the expensive one, right? Is like $75.
No.
It just like it just doesn't make a whole lot of sense if I'm going to be trying to just spend all this time, years, because this is not a short-term project. This is long-term work right here. It's like if I'm going to be spending years on something that can be done on a $75 chip versus, your $1,000, $10,000, multi-million-dollar infrastructure, I'm going to build it on the cheapest one, and then once it's built, then you can go and you can then take this off of the $75 infrastructure and drop it onto whatever expensive thing you want. It could be multi-million-dollar infrastructure that's designed to chew on terabytes of data per second or whatever.
Yep.
Terabytes per second.
But it's a lot easier to scale up than down.
Yeah, yes, and that's the reality there. Is just as Jordan said, that's actually a really good point. I'm actually going to write that point down. It's a lot easier to scale up than down. And so really, it's easiest to just start with what you could otherwise call this like minimum viable product development or MVP development. So we could just say, if you're trying to build software for the first time, or you're trying to do something, you're ultimately trying to build a minimum viable product. So I guess if I were to just tag that, we could say yeah, so if you're trying to develop something new or just experiment, or you're trying to do some of these things, if you're doing minimum viable product development, you're trying to create some new technology no one's ever heard of and things like that, you're basically taking a risk. You're basically saying, I'm going to try to do something that no one has ever tried to do before, which means it's almost certain that you're going to fail much more often than succeed with what you're trying to do, by a lot. Which means that this $75, or this $10,000, over time, it's not just one $75 thing. It ends up becoming a lot more. And even here, it's like as our operations have grown, It's like I need to be able to make sure that we can get the appropriate hardware that we use for our minimum viable product development over to Jordan, over to our other team members, which we're going to do a huge announcement on the Cloud Underground and talk about this whole what is the Cloud Underground? What's going on with the Cloud Underground? Why am I not talking about the Cloud Underground? We're not going to talk about the Cloud Underground right now because we're going to talk about it later. But like, why is it that we don't want to spend a whole lot of money on things when we're trying to like build stuff? Is also like when you're trying to also just build new technologies, it's a lot like learning. So what if you're not trying to build minimum viable products and you just want to learn, right? And it's kind of similar with like software engineering and learning. If you're a developer or you're an engineer or you're a scientist of any sort, or you're doing just going to school, you don't even have to go to college to feel the pain of how expensive education is. Because if you try to get like a Google education, you're going to pay in time. If you go to college, you're going to pay in money to go talk to other people and pick their brains, which they're going to give you their time, which that's a whole nother thing. And then other people got to get paid out of it. And so, like, no matter how you're going to try to learn, it's either going to be time or money that you're spending, and a lot of it by a lot.
Potentially both.
Yeah, yeah, that's true. So we'll just say time and money, and there's just no avoiding it. Like you can try to spend less money on education, you'll probably spend more time, depending. And there are some things that just cost more money than they need to. Sure, yes, that's definitely a thing. But having an instructor, because one person was asking me, like, well, I want to try to self-teach, but I like having someone who can teach me and do all the things with me. Do you think I should try to self-teach or should I go to college? I'm like, well, how much do you value having that person with you? That by itself can be worth going to college, because I mean, I went to college, and if you want to be able to have a place to be with people. Now, right now, we're in like lockdown times, which is a little different times in the world in general. But still, being able to go into an infrastructure where you can get connected with a person who does what you're trying to figure out regularly, and that's like all they do, and they spend no other time doing these things. Like, it's just a whole lot. It's a whole lot of everything. And so, like, Kubernetes is time consuming to learn, and it's time consuming to build with. And so even though you can actually learn Kubernetes for free, I'm not going to tell you that you can learn Kubernetes for free, because if you try to learn Kubernetes for free, that might take you like a year, and that's not free. I can't put that on my conscience, because the reality is you have to make sure that you have the availability and other things. And if you're going to, yeah, you got to make time for it. Time is money. That's the bottom line, I guess. So that's something that I've been I've been running into that a whole lot, and I've been wanting to talk about like the fact that like time is money and all these things. And so if you're trying to learn Kubernetes, because I get a lot of people like asking the question, well, how do I learn Kubernetes in the first place? Well, what do you do with Kubernetes? Well, Kubernetes will run on just about anything, but I would say if you're trying to learn Kubernetes, if you're trying to learn Kubernetes, put most in what you're paying, in my opinion, like into the learning of it, like the education pieces. And even we do that, where we do sell things with Raspberry Pis. And while if you look at the price tag, it might look like it costs a lot, what do? Most of what you're paying for is education. We sell an entire like set of workshops and things like that. And right now, this is not me advertising. I'm just talking about like cost and like what do we charge for certain things. So really, if you want to try to learn something like Kubernetes, don't make the hardware the expensive part. Go spend your money on the education part. Spend your money on the workshops. Spend your money on labs or something along those lines, or anything that might help expedite. Because if you're trying to learn Kubernetes, it's already going to take you a long time, and that's just an unavoidable thing. And that's okay.
And if it's just as easy to learn on a Raspberry Pi as it is on something else, then $60 for Raspberry Pi or a few Raspberry Pis, and
Yeah.
then if it doesn't pan out, you're not out that much. You're not out a $10,000 server or something like that.
Right, especially if you're trying to do it for like a yeah, that's true because you might be trying to get a job and that, or you just might discover you hate working with Kubernetes and you're like, you know what, I hate doing this and I don't want to do it every day. And it's like
No.
some other things. It's like once you have like once you kind of have a general understanding of Kubernetes, then you can come in and you can either use like old machines. So maybe I just put some examples of like maybe some hardware that we might recommend, like good hardware for learning Kubernetes, because it doesn't necessarily, because we use Jetson Nanos as well, because there's the question of learning and building, because in a lot of ways that's kind of the same thing. If you can learn it on something, you can also build it on something. I guess it depends on what your goals are and what you're trying to accomplish, but like obviously I'll just start by just saying the Raspberry Pi. Raspberry Pi is a great way to start learning Kubernetes for those who are like, well, what's an affordable way to start? And then, of course, I mentioned the Jetson Nano, which we'll mention again. And then some other things, because we have Raspberry Pi, we have Jetson Nano, and then like let's say that you have like because you don't spend a lot of money on stuff, in my opinion. You know,
Yeah, like old lab thing that's hanging around.
Yeah, 100%.
Old desktop.
Oh, totally. Let me write that down too, because
buy some cheap computer pieces off of eBay or something. Build yourself a really cheap computer.
You know, eBay's gold. You're trying to learn this stuff. Like eBay is a gold mine for hardware if you're trying to learn these things for the first time. Even if you're not trying to learn it for the first time and you're just trying to like put together just a quick, you know, bootstrap setup, and you're just like, how can I get going? You know, you could get all of the above and cluster them all together, because that's what Kubernetes is capable of, or you can run them all independently. And so like if we were to then say like maybe you start on one and then you're ready to start learning how to scale or trying to make Kubernetes work with different things, you can then make Kubernetes turn all of these into basically one supercomputer, which is something that you can do. And from an educational standpoint, you'll learn quite a lot. So if we're trying to develop like one supercomputer, like it can be developed really just about anyway. And so this would be considered maybe like hybrid cloud. Now, if you're getting into like the upper echelons of like trying to get into like top performance and all these other things, there's a lot more inner workings you might want to think about and care about. And there's like polling you have to care about. You have to care about like the telemetry of things. You have to care about like all these other little variables that come into place, like all these offset configurations, like conflicting ports, and who knows, and also like latency, all kinds of stuff that gets in the way. But you know, if you're just trying to learn, honestly, you can just learn how to just take all of your stuff and then just make all of them friends, because they can all be friends. And that's something that's kind of interesting. So I'll even just write that right there, is everything can be friends. I think that's one of the things that really drew me to because I like software that's generally somewhat universally compatible, or as universally compatible as it can be. And Kubernetes overall is pretty agnostic. It's pretty general. So it's like, and then one of the things I like about it is like, oh, so I can build something on a Raspberry, well, on whatever I have. It doesn't even have to be Raspberry Pi. What do I have? Maybe I have an old laptop. Maybe I have an old desktop. Maybe I have both. Well, you can start building actual solutions no matter what you have, more or less, unless all you have is a cell phone. And believe it or not, you can hack a cell phone, and some of them you can actually put Docker Kubernetes on some cell phones. You might have to go and hack it, but they have ARM processors, which is like a Raspberry Pi on a lot of them. Some of them have like Snapdragons or whatever, but there's a bunch of different processor types. But if it's an ARM based processor, some of them you can install you know, things like custom operating systems and other different types of things. So, yeah, and then hey, we got some people jumping into the chat. Thanks for joining us. But yeah, mostly just kind of talking about what kinds of hardware is good for learning Kubernetes on. What is one of the other strange things that I've come to learn about Kubernetes that some of you may or may not find interesting? But containerization, it's just so portable and modular. I'm just going to say containerization in Kubernetes. So this is something else that's really interesting about Kubernetes, because going back to that whole idea of like universal compatibility and things that all can work together and be friendly together, one of the things that is, I get this question, you're like, what does Docker have to do with Kubernetes? Well, we build for Kubernetes in Docker and with Docker. And so one weird thing about Kubernetes is Kubernetes plays well with other things. Because, you know, if you ever play with Kubernetes, you're inevitably going to run into the idea that Kubernetes runs off of container images. That's like an inevitable thing that you'll identify. And container images work in things beyond Kubernetes. So some of the other examples of where you might see containerization is Docker, and then I think there's like LXC or LXD. LXC? Actually, I think it's LXC. LXC containerization.
Yes, it looks like LXC.
Yeah, there we go. And so on. So if we have other things like Docker, and then we have LXC and some of these other tools, really you can just kind of save whatever you're trying to do with like maybe for Kubernetes in Docker or LXC, or you can make them all play together. And other things that are interesting is you can take Docker or LXC and some of these other things, and you can put Kubernetes inside of them. Which sounds kind of confusing, and maybe that's not the best way for me to explain that. But you can basically run Docker in Docker, Kubernetes in Docker. You can run Kubernetes in LXC. you can run Kubernetes in a Kubernetes container or Kubernetes image. So Kubernetes is just a very kind of, it's just fascinating because it's like this weird data structure that lets you kind of move things around and connect things that maybe shouldn't connect, and it lets you make things talk that shouldn't talk. And I like to make things talk that shouldn't talk. So I guess like, so Jordan, when you were first thinking about like things like Kubernetes, like I guess what were the things that are the most confusing to you? Because I always thought it was kind of just such a strange technology.
Yeah, well, I mean, I think like setting the ports up correctly to make everything play well and talk together. I don't know. That seems like one of the more complicated sort of aspects to it.
Yeah,
setting
really
all those ports up.
Ports are super confusing when you like,
especially when you start doing this Russian doll thing where you've got Kubernetes and Docker and Kubernetes, and it's like, I don't know, how does that setting up all those ports has got to be pretty interesting.
And you know, ports do get confusing because you have ports for your containers, then you have ports for the hosts of the containers, then your ports have to all connect. And then let's say that you have a container that's running on an ingress and an egress network. Then you also have to know what an ingress and an egress network is, and you have to make sure that the ports all agree on the appropriate networks. Honestly, that stuff gets confusing. And it's easy to even like you might know what you're doing, and then it takes one day where you're just exhausted, and then you might spend like all night doing something, and then you come back and look at it and you're like, no wonder nothing worked. I don't know what I was thinking. Like I guess if I were to even pull up like let's just take a look at some container stuff. Like if I go to Portainer. So right now I'm building Kubernetes in Docker containers. Is a thing that I'm doing. Just various reasons. I have my reasons for building Kubernetes in Docker containers, and then what that comes with is port madness. So if we take a look at some of the ports here, let me move the things around on the screen so you can see some of this chaos. On the right hand side, we can see this ports published thing right here. And in a development center, it's really easy to just forget what was supposed to be a development thing unless you like label well. But sometimes you get making sure that you can like properly manage ports, and then let's say that you're trying to build some sort of file or something, and then you forgot that you had used a certain port while developing, but then once you're done developing the thing, maybe it wasn't supposed to use that port. Now you have a vulnerability. Like that's how vulnerabilities are born also, is port madness and not having the ports under control, because then someone's gonna swoop like, hey, open ports, it's a field day. I was talking to, and actually, that interview is on my YouTube channel for anyone who's watching and wants to know more about this. Is if you go back and look at an interview with Q, a guy named Q, who works with Palo Alto Networks. One of the things that people run into with pen tests is that people will just leave their ports wide open because they don't want to deal with the ports, because the ports can be confusing. And like that's the last thing you should do. And it's so funny because it's so predominant that people just, instead of just trying to understand the ports, like what Jordan's talking about, Jordan's like, I'm going to understand the ports, but what most people do, instead of trying to understand it, they're just like, let's just leave all the doors open. I was just like,
we can get it easy that way.
Oh my gosh, man, it's so bad. And like, if you go and like look at because we run a DevSecOps dojo, and at some point when we start getting blueprints when people are working on their projects, because the projects we do in the DevSecOps dojo, they take months, like 6 months to get to like a base foundational item. So you can also learn Kubernetes in the DevSecOps dojo if you want to learn on a track, because that's what we do all the time. So I work professionally with Kubernetes, Docker, containerization, all those things, and right now, I decided to work exclusively with Blumira. So I work exclusively with Blumira, and then we teach these types of things and the philosophies around development in the DevSecOps dojo on Thursdays, which is where you will find us. And something else that we do, because we're talking about like hardware and things like that, is one thing I like about Kubernetes, you can build your own products if you can find things like open source hardware. And so Kubernetes plus open source hardware is my jam. I love this whole concept. Is Kubernetes makes open source hardware more exciting. Because if we think about open source hardware, that's like hardware that, more or less, if it's not community supported, it generally doesn't get any support at all. And so if we think about like the Raspberry Pi, like even if I go over to their website, like Raspberry Pi, well, that's not their website, .org, here we go. So if we go over to Raspberry Pi, in order for the Raspberry Pi to actually have some form of value, the people who produce the Raspberry Pi have to come up with like use cases of like what's going to make this thing change your life. And notice a lot of it is like around education, like learn at home. And we're talking about, why is it that we use Kubernetes or use Raspberry Pi for learning things and teaching things, and all. Raspberry Pi is just so painfully affordable for just trying to educate, and especially from home, where it's like, hey, we can send you a Raspberry Pi, and for the cost of like maybe some other company has a $500 workshop that's just a workshop. Raspberry Pi is so affordable that $500 can also come with the Raspberry Pi, or the $800 that might be education only otherwise can come with the because they make it affordable. This is what the Raspberry Pi really does. And the problem with like open hardware, once again, like Windows is something where they have money to produce like supporting applications and things like that. So like if you want to play games, like Windows is the most heavily supported operating system for gaming developers and stuff like that, because it's a platform that is built to make it affordable for people to build games on and build applications on and business software and whatever, you name it. But with open source stuff, you kind of have to just figure it all out on your own. There's a lot less guidance. You can't call certain help desk centers. Like to create these dashboards, there is no calling a help desk center and being like, hey, I'm having a bug with this Raspberry Pi. Well, the Raspberry Pi is not generating the dashboard. Well, why is the dashboard not working? Well, that's the problem you have with open source hardware. Is like it's not like a Dell laptop. Dell laptop, you call Dell. Why is it not working? And then they're like, don't worry, you have warranty. We'll send you another one. And so the nice thing about like open hardware is you can become Dell in a way, where you can come in and be like, okay, so it's open hardware. It's affordable for me to like build my software on, and the cost is so low that I can make sure that we can like have a whole platform and things like that. And the Raspberry Pi has made it so affordable for people to run their businesses and build their software platforms and build their stuff. Like one of these people in our environment, Todd Byers, I know you don't mind me talking about you. If you look up Todd Byers, he makes monoliths, supercomputers that are outdoor like marble supercomputers built on like a
Art
Raspberry.
installations.
Yeah, it's like art, hardware as art or something. You know, like how cool does it get? But why can we all of a sudden do all these like different things? It's because it's open source hardware and you can turn it into like whatever you want. You could turn it into a drone. You can have a drone that you give teach AI to or something like that, where maybe the drone follows you around because this crazy AI you wrote that also has dashboards inside of it that you can access from your phone. I don't know why you do all that, but the fact of the matter is open hardware, you can then like package that whole thing and then make it your product and your thing, and then you can go and help people with this thing that you created, which I always thought was really interesting. But like Kubernetes makes open source hardware exciting because it gives like there's just you can almost already do too much with Kubernetes already, but you can build so many things. And I guess maybe that sounds like somewhat generic or whatever, but it's like your standard person who goes and they're just like, I just want a computer to do my job. Open source hardware is probably the worst thing they should probably ever consider buying. Go get a Windows computer that can run a browser. You can watch YouTube on it, and you can do basic word processing. But what if you want to do this stuff? All of a sudden, coming up with like some of these other things like open source hardware becomes so much more valuable, especially with like open source software. And I feel very much so that like open source hardware and open source software play really well together. Jordan, what are your thoughts on open source hardware combined with open source software? Like, I guess that combo where it's not just the hardware, not just the software.
Well, I mean, I think it makes a lot of sense, just because if everything is open source, I think it makes it easier for the software developers to develop for your hardware, right? And I would think that it would make it a little bit easier just to, I mean, really tailor programs to whatever system you're running them on. So I don't know if I've got a lot more to say on it than that.
Yeah, it's definitely interesting because it's like, since we use open source hardware, it's like we can even put our own cases on it. And while we put powered by Raspberry Pi and things, I guess let me pull up Jordan, should we show them the new case cover concept, or is it too soon?
Sure.
Okay. So I'm going to show you a new concept we've been working on. So soon we're about to announce a whole lot of things, and those who've been following us in the past have seen, like, you know, we'll normally show off a lot of the things we've been working on, but we're in a good situation where we have a lot of development power behind us right now, where we have funding and time and all the things to really try to get some stuff right. And then we're going to be making a really big splash once we get just a little further here with what we're doing, but we're very close. So I've been working on the software. Jordan's been working on the hardware, and we've been working on the software together too. So Jordan has a hand in the software. Let's see. Where is the thing? There it is. So we've shown our cases off before, but we've decided to kind of retool a lot of the feel and how it's all going to kind of look and things like that. And so the Olympiad is a platform that we've been working on. And the Olympiad really is a collection of it's a software platform that's really it's an infrastructure platform. Well, maybe let me move this to the side a little bit. And what I mean by an infrastructure platform, because that's probably a confusing thing to say. How do I explain or describe that appropriately? So, like, a Docker container, and Kubernetes uses something called infrastructure as code. And so it takes the concept of hardware, and then it gives you this ability to make that hardware like software sort of a thing. But then you still have to have hardware to contain the containers. And so what the Olympiad is it's infrastructure that's designed for managing and maintaining infrastructure as code. Which, if you don't know what infrastructure as code is, maybe I've made videos on that in the past, but maybe we'll talk about, maybe that's a whole topic that we could talk about sometime. But Jordan, what was some of your inspiration on this? Because I think this is super cool. Like, what's some of your inspiration on like the design? Because I'm a big fan of this design.
Well, when I was hanging out with you guys, you wanted me to print a little lid with a lightning bolt on it, and I mocked something up in like 5 minutes that was, whatever. It had a lightning bolt on it, but it wasn't that exciting. But I like the idea, so I kind of just wanted to, I guess, flesh that idea out a little more. So I kind of, I like the cloud because we're building the whole, cloud underground. So I kind of thought it went with our theme, and then I just, designed some lightning around that, and I wanted, I didn't want a single bolt. I kind of wanted, the like big strike that has a lot of arms and stuff. And
I love that you did the arms and the veins. Like it looks so. And then I like that the yellow on the raspberry is slightly different from the lightning.
yeah. Well, yeah, totally. And yeah, I don't know. I just kind of thought of the idea of having it hit the raspberry, since I kind of wanted that to be on the case, and it's like, well, if lightning's hitting it, it should be on fire. So I kind of like put some flames around it. I don't know. Anyway,
it's definitely on fire. As a matter of fact, yeah.
Go ahead.
The lightning bolt. I love the light. I guess I should show everyone the lightning bolt because it's like right around the corner. So let me just show everyone because exactly like Jordan said, I was like, yeah, something with the lightning bolt would be sweet, and it was sweet. And then he made this, which is even sweeter. Let me show you.
Well, lightning's something. It's nice because it's like easy to mock that up. You just make basically squiggly lines that go in random directions. Sorry if I keep getting distracted. There's a stupid cat running around, but
So this is sick. So this is let's see the reflections a little. Let's see if I can get it to not be too reflective. It's actually like a dark gray, but it's like a cool like shiny like metallic looking gray. So in the light it just looks like a bright gray. But there's the lightning bolt. And so this is a kit that I've been putting together because we're putting together a bunch of different kits because we are launching like a long-standing, like more or less like a permanent production cloud, and we're going to be running our production cloud off of these things. Right now our whole development systems are all running off of these systems and all that good stuff. But Kubernetes makes it easy to do this stuff. Like because of Kubernetes, you make a whole platform, man. I think, like, to
Mm,
me, that is crazy.
yeah,
Like, all the way from the hardware, because like the Raspberry Pi is just open hardware, and open hardware, I guess Broadcom is like a not quite an open component of it. But aside from Broadcom, like it's even the Jetson Nano doesn't have that on the Raspberry Pi. The problem with the
sure.
Jetson Nano is it's not true open hardware to the same way. And Jetson Nano, we use them as brokers, and they're great for like having like a nice little standardized kit. But when you want to have just like, we mess with the clocks on these things. You can like overclock them to 2.0 gigahertz or high. What's the highest you've overclocked one of these to so far?
2.3. I've definitely gotten to 2.3. I
Yeah.
don't think maybe I've done 2.4. I'm not sure. Supposedly you can get to 2.5, but I think that might be silicone dependent.
Sure, sure. Yeah, honestly, like that's quite the kick. Uh, and you know, these things are tiny. There are laptops out there still with like 1.5 gigahertz like
Sure.
speeds on those processors and things like that. And
Well, and the
so
fact that you have 4 cores, in addition to the fact that they can run at 2+ gigahertz, and it's 4 cores, 4 threads. Is that correct?
that's right. Yeah, four cores, four threads. And for those who are like Linux native people who like Linux terms and things like that, a Raspberry Pi is just an EC2 instance. That's all. That, like just like any other EC2 instance. So if when we're talking about the concept of an EC2 instance, it doesn't care what the hardware is. Outside of, we do care about whether it's like so there's the concept of like architecture. You have to worry about like the type of processor. Is it an ARM processor? Is it an x86 processor? Is it, what kind of processor is it? Uh, so that aside, if we moved that to the side, then Linux, if you're trying to just build like Linux systems and build applications, a lot of applications, especially like enterprise applications and uh, you know large cloud applications and things like that, like they run off of EC2 instances. And the Raspberry Pi is just one of the most painfully affordable ways to have an EC2 instance to develop on, which is
Hmm.
why like developers like us are just like, hey, let's go. Like it's just that simple. And I work with a bunch of other, maybe not work with directly per se. Well, I do work with a lot of other developers, but anyways, like there's some other people who I work with in our ecosystem in the open source space who, just because the fact that the Raspberry Pi is open, like the monolith, for example, from Todd Byers and those people,
Hmm.
it's like you can create art with literal granite because it's a granite Raspberry Pi supercomputer. Because it's just an open source EC2 instance where you can just express what you want. You can have like the case you want, you can have the software you want, and because Kubernetes lets you have, like, in a lot of ways, Kubernetes brings a lot of freedom. So I guess that kind of goes over most of like my thoughts. It's like Kubernetes plus like open source hardware is just a lot of freedom in a lot of ways, especially for people who are trying to build careers in like the development space or engineering space in general, because now engineering and development are kind of all bleeding together these days. But yeah, so I guess, Jordan, do you have any thoughts, I guess, like because I know we've been streaming for a while, but any last thoughts before we wrap up?
Well, one thing that I was kind of thinking about while we were having this conversation, and maybe it's going to be too much of a tangent to get off onto, but I think one thing that, we're talking about, if you want to get into developing Kubernetes, what kind of system to put it on. I think another thing to think about when you're, getting ready to develop with Kubernetes is really what is your use case going to be?
Totally.
Because if you kind of go in without any like real direction, I think it can be hard to decide what to do because there's so many options, and it helps focus you to kind of have a goal and to know what you want to do. And it makes it a lot easier to find resources that will help you make that possible.
I would agree with
So
that.
yeah, I don't know. That's the kind of extra thought that I've been thinking about while we've been sitting here.
That's actually, before we go, that's actually worth kind of outlining because it's so true. Exactly what
No.
Jordan said. Anyone who has been dealing with any form of like development, it's really easy to sit there and be like, okay, so I'm sitting here in lines of code. As a matter of fact, let me go ahead and just sit here in lines of code as right here. Here we go. So I've just changed my background to. We're sitting here in lines of code, and there's like so much information, and there's so much going on, and there's Kubernetes, and there's all this hardware, and there's all this chaos, and there's all this and really, it does just feel like madness because I think about my students and the people we mentor, and like Jordan's talked to everyone too, and it's just like even Jordan and myself, it's like it's so much.
Yeah, no, it is. It is.
Like I remember when we first started doing like the tournaments, we had a use case before we touched Kubernetes. Our use case drove us to Kubernetes. We were like,
Yep.
oh, how in the world are we going to accomplish this thing? And we thought of so many things. We were just like, well, we could try this. I'm like, nope, dead end. And we're like, well, we could, nope, dead end. And it was just like dead end after dead end. And at one point, we even went to AWS. And there's nothing wrong with AWS. It has its business benefits. It has. I work with AWS for business on a daily basis. It's like one of my primary integrations projects at my primary project right now. And like, not even just that. I can't talk too much about a lot of those things, but like, really, there was nothing that allowed me to accomplish what I wanted to do. And then with what Jordan was doing with us, there was nothing that we could really just kind of wrap our heads around that worked. And then all of a sudden it just came down to Kubernetes. And then the downside of Kubernetes is, oh, well, that's quite a lot.
Yeah, it's just complicated to figure out.
Yeah, and then like a year later, we're like sitting here after thinking about like, oh, Kubernetes, okay. Now it's like a year later, and here we are, like still packaging these things where it's like, let's see, let me get that the dashboard back up. But it's like we already had a use case before this dashboard existed. And without a dashboard, I don't even know what I would do with Kubernetes. And it really just came down to we're like, well, I don't know how to accomplish building a security operations center that's modular, that is proper full SIM, that lets us pull data from all these other random sources easily and effortlessly without a whole lot of chaos, and networks with everything. It's like this was almost too ambitious of a project initially, other than the fact that we didn't stop. And here we are. So I guess it wasn't too ambitious because here we are with the Security Operations Center software that we're packaging, but it's thanks to Kubernetes. And
Sure.
just like you're saying, I guess if I were to just kind of put that there because it's worth people who are watching visually, I guess. It's like there's a YouTube video, and actually I'll just pull up that YouTube video. But Kubernetes without having a use case, it's just too much. I guess maybe that's just the blunt way to put it. There's just too much of everything. There's too many options. There's too many things you can do. There's too many things you can build. There's too many things you could come up with. And so, like, one thing, if anyone just wants me to give them something to just start building today without trying to figure out something, because that's a good point. Maybe I'll end it on this because this is a good point. Is you can build a Minecraft server on well, it doesn't have to be Raspberry Pi, but you can build a Minecraft server. You can go to YouTube and you can say build, let's see, Minecraft server Raspberry Pi Kubernetes. Bam. This is awesome. So
in the last episode, I showed you how to install Kubernetes on the Turing Pi cluster running on 7 Raspberry Pi.
That's just some. You can go to YouTube yourself and watch more of it, but let me go over to the parts that are interesting in this, because this is just one use case. You can literally just spend 1 hour on this and then go back and then build your own and then learn Kubernetes this way. Whatever you want to do, really. This is even on Raspberry Pi 3s, I think. And so Raspberry Pi 4 is even more powerful than 3. And, you know, there's something on here that, bam, this somehow looks familiar. See, we have this little symbol right here, which looks oddly familiar to this little symbol right here. What is going on in the world? Yeah. But this is an incredible video because this person is using basically dashboards to monitor their Minecraft server and running Minecraft on a Kubernetes cluster. So you can run Minecraft in Kubernetes. Let me see if I can find... They're showing Minecraft, because while I'm saying the word Minecraft, seeing is believing. Oh, there you go. There's some targets. Everyone loves targets.
Well, and just while Nathan's kind of scrubbing through the video, I want to say anybody who's interested in Raspberry Pis, Kubernetes, anything like that, definitely go check out Jeff Greerling's YouTube website or his channel. It's awesome. He has so much cool stuff.
Oh, it's so awesome. It's funny. It's interesting because he uses Pi-hole too. We use Pi-hole. He uses Pi-hole. Is it a coincidence that he uses Grafana and Pi-hole? I didn't even know that anyone else out there used Grafana and Pi-hole together for any reason. And I was like, whoa, what a beautiful combination. And lo and behold, you find out that there are other people who use the same things. Oh, and he shows like integrating the data in a different way. But hold on, let me find. Oh, where's what I want to find? It's in here. It's here somewhere. I'm being a terrible stream host because I'm not finding the one little thing I'm looking for. I'm like I should have like thought about this ahead of time or something. Oh, all I want to do is find the part. So I'll just explain what I'm looking at. You can watch the video yourself, I guess. You can just Google exactly what I Googled, which is Raspberry Pi Minecraft server Kubernetes. Bam, there you go. Oh, here it is. I found it. Look, it's real.
Minecraft on a Raspberry Pi is not necessarily the fastest thing in the world, but if there's one thing I remember from Minecraft before, it was something like you're supposed to dig straight down.
Yeah.
So Minecraft is really fun, and it may or may not be the best.
Okay, and so it may or may not be the best of whatever, but now you know use cases matter. If you don't have a use case for doing, honestly, I think video games are one of the best use cases for learning on the planet. Like I learned most of my technical knowledge from video games because I like to mod games and I like to tinker with video games.
I mean, all my early networking experience came from trying to figure out how to set up LANs to play whatever StarCraft or Battle 1942 or whatever it was.
You know, it's such a thing. It's such a thing because it's like LAN parties. LAN parties are fun, man.
Mm-hmm.
We've even LAN partied. I remember we spent maybe one time spending more time configuring configuring the network to let us play like a game in a local instance without having multiple license of the game than actually playing the game, and that was fun. It was a good time. We need to play that more sometime. Maybe we should do.
We should. I'll tell you what, it's a lot easier to figure that stuff out now than it was during the Windows ME days, which is when I was learning that stuff.
I could see that. Yeah,
Windows ME was so bad.
Technology has gotten much easier to work with, like the networking technologies and all that stuff, because you know, I remember back in the day, like routers didn't have a little login where you could like log into the router.
Yeah, totally.
Totally. If you didn't know how to use a BIOS or like the little command line thing where you go in there in the Cisco router and it's like enter this thing for this mode, enter this thing for this mode. Like that was confusing.
Yep.
Technology's come along.
Yeah, now they have nice GUIs and it's all really pretty, and at least if you get a good router.
It's so true. It's like, yeah, you know, if you you spend at least $50 on a router and you'll have like some sort of decent little login with features and options and an easy way to set up your password. But yeah, so I guess that's.
All right, we're getting off onto tangents now, but It's funny. I actually recently set up my router so that my computer has like a gaming preference, and it's made such a world of difference for everything. It's I don't know. It's made my life a lot better. It's funny.
Totally. Oh man. Oh, I guess we have some people in the chat too. It says hello. I keep sounding like a broken record. Anyone with beta access to Google Open API GPT-3, I'm still looking to get anywhere. Oh, I don't know if I've ever looked at. Well, I've looked at that in the past, but I haven't spent a whole lot of time. It's probably something that's worth playing with. Like Google Open API GPT-3. More about this, and this is the type of stuff that I like too, because this is what I spend my spare time on is things like this. Interesting. Open AI. Well, this is something that I'll have to dig into at some point. But yeah, all the different things. Yeah, thanks for watching the stream, everyone. We're gonna keep doing more of these, and then maybe we at some point we more like AI type things and stuff like that. Because right now we're gonna be adding Jetson Nanos to our cluster and playing with AI anyways. At some point, it's kind of a slow grow, so we're gonna move as fast as we can. But you know, we've been doing it this long. It's kind of hard to like. This stuff is so complicated that sometimes it just takes a long time. And then, but now we have funding too, which is a lot different, and we have a much better structure for moving forward here. We'll have fun with it. We'll come up with some cool stuff, and I do want to get into the AI stuff when we get there because the Jetsons make it fun. So we'll get into that.
It's gonna be neat.
So, all right. Well, thanks for watching the stream. I'll go ahead and wrap up the stream.